Hello, good morning. Here we are, chapter 11.3, sector area and arc length. Only a couple more of these to go, and summer will be here. So hang in there, you can do it. And I'm here to help. Miss you guys, hope you're doing well. Hope to see you soon before the school year lets out. But okay, we've got some definitions. We're going to keep working with circles, and we're going to be learning how to find areas and arc lengths of certain sections of circles. Okay, and so that's what sector area actually is. Sector area is the partial area, so it's not an entire circle, partial area of a circle bounded by two radii and an inscribed angle. Okay, wonderful definition. Well, let's just look at the picture here. So you've got yourself a circle, and so we know how to find the area of an entire circle whenever we use the radius. Okay, right? Pi r squared. So this is now, what if we need a fractional piece of a circle? So if we've got something like this, here's the two radii, so don't let that, and here's the inscribed angle. All that means is that whenever you see this, you can always know these lines are the radius, and this is in fact the center of the circle. And sector area is then, okay, I need to find this piece of the area. I need to find this slice of the pie. How big of a piece of pizza am I actually going to get, or whatever. And so that's where so the big question today is, how do I find that area? And honestly, I think it's fairly simple, because what we want to think of is we want to think of this as a fractional piece of the whole, okay? And that's why this inscribed angle is so key, because if I know the angle of this right here, so if I know what this angle is, then I know what fractional piece of the total. Let's just say so if I can take the measurement of the angle and put that over 360, that is basically my fractional piece, kind of my percentage that this red shaded region is. And so then what we've been learning, or what you know, is that if you multiply the fractional piece times the whole, you'll get the other half. So in other words, if I want half of something, I take the total amount of it and I multiply it by a half. If I want a third of something, I take the total amount of it and I multiply by 1/3, etc., etc. 4/5, I take the whole amount and I multiply by 4/5. So the way sector area works is you take the degrees they give you over 360, that's your fractional part, and then you're just going to multiply by the whole. Okay, so what's the whole of this circle? Well, it's the area of this circle, which you already know, pi r squared. And so our formula for this lesson is fairly straightforward. It's simply the total area. I'll go ahead and label these. It's the total area multiplied by the fractional piece. Because like in a simple example, we've done this before. If this was a semicircle with just half of it, you would find the area and you'd multiply by a half, 1/2. Well, in this case, the angle measurement of that half would be 180. 180 over 360 would be the same as 1/2. And so all you do on these problems is you just find the full area, and then you make a fraction out of the number of degrees in the sector that you're looking for and multiply that together. And we'll do some examples, and you'll see it's pretty straightforward. As long as you keep in mind, I got to use the area formula for sector area. Okay, area is pi r squared, and that'll vary when we get down here to arc length. Okay, so segment of an area. So segment of an area is slightly different, and I'll draw it first, and then I'll describe it. So segment area is then, say you take a sector, and then you take a chord, which is a line between 2 points on a circle, and you connect those points. And so, not kind of small here, but so a segment is then what I call the fingernail, or the pizza crust, is this piece right here, where you have a triangle cutting off the overall sector. So it's the same as a sector, but then you've got the chord going across here, and so you're only using the fingernail or the pizza crust, and that's what you want. So it's the area between an arc and a chord would be a simple definition, because it's the area between, here's my arc between A and B, and then there's a straight line chord between A and B, and so that's the other piece. And again, I'm going to stick with, I like that analogy, the pizza crust, because we all like pizza and we can hopefully visualize that. Sector area is the pizza area, and then if you just want to know how much you are not going to eat because you don't like crust, I know some of you, there's somebody out there who actually like only the crust. Weirdo. But this is the area of the pizza crust. And the question down here, we'll talk about how to find the area of that. Okay? In order to do that, I've actually given a definition here that's not in the book, because the way the book tells you to do it, I think, is a lot harder than a simple formula that I can give you that I know you're going to be using in Algebra 2 anyway. And so I've said, go ahead and look this up online, the trig area of a triangle. But if you're watching this video, here's the formula. You can do it the way in the book. Go ahead. Carry on. You know how to work hard and find the height and the base and solve for the area of these triangles, which, again, we'll talk about down here why you have to do. But let me please give you a shortcut. A way to find the area of a triangle, we know the formula A equals 1/2 base times height. But there are a lot of triangles when it's not so easy, and maybe you've done this, finding the base and height can be hard. So there's another formula. I'm going to cross this one out, symbolizing I recommend you do not use this formula, and that you instead use a formula of area equals 1/2 AB sine C. And you might say, holy cow, Mr. Medford, that looks horrible. Well, let me just show you what that means. I can draw any random triangle, and normally you'd have to find the base, and then I'd have to find the height. What this formula says is if I know one side, I know another side, and I know the angle in between them, then I can find the area by multiplying this side by that side, sine, and then sine of this angle. Sine of this angle. Now you're going to see this is really important, because that's exactly what is described whenever you're doing these sector areas. That I'm going to be able to find the area of a triangle formed in here very easily, because I've got my two sides, and you're going to know this angle in between them. This is a side angle side relationship. And again, this will be demonstrated in the questions, but I highly recommend this formula, because you're going to be able to solve certain problems in this section so much faster if you just learn that habit of, you just multiply the two sides times the sine, use a calculator, the sine of the angle, and divide by 2, 1/2. And you'll be able to find any triangle of any shape. You don't have to sit there and try to find the altitude and the actual height. If you don't know it, you can simply use an angle and the two adjacent sides. Okay, let's go to arc length. And again, these will be demonstrated soon. Arc length is basically the corollary, or the sister, the cousin, whatever, of sector area. Where, we in most shapes we have area and perimeter. Well, arc length is the perimeter equivalent of what we did up here. It's the partial circumference of a circle bounded by, we'll say the whole thing again, 2 radii and inscribed angle. Okay, so you've got a circle, same exact thing. I'll make a slightly different one. But now I don't want the whole area, I want the arc length. So I want this distance. Maybe I'll use black here I'm looking for this right here. Okay, between A and B. And so I'm not looking for the whole area, I'm just looking for this piece. And so the principle, though, is exactly the same as what we said up here. This is a fractional piece of the entire circumference. So the fractional piece you'll find this by taking the measurement of this angle, whatever this angle is. Okay, I put a little theta there, over 360 times the whole. Now the whole for a circle, for circumference is not pi r squared, but pi d. And I'm going to use pi d just to make it look much different than the area formula. So sector length, or I'm sorry, sector length, which is kind of what it is. Arc length is the fractional part, same thing here, times total circumference. And I'll go ahead and do the same thing. The total circumference is pi d, which if you know the radius, finding the diameter is super easy. You just double it, times, again, the fractional part. The biggest mistake you'll make is you want to, whenever you're solving these, is whether you use pi d or pi r squared. Otherwise, the operation is the same. This will give me the fractional area. This will give me the fractional circumference or arc length. Okay, let's look at some examples or answer the 2 questions, and then number 3 causes us to work through all 3 skills you'll be using in 11.3. Okay, so number 1 asks, how do you find the area of a segment or pizza crust? Okay, how do you find that? Well, what you can see is if you have a sector area, it looks like this. Okay, it's a fractional part of a larger circle. And so you have the whole thing. And in order to find just the segment area, then you need to, from that total sector area, you need to subtract this triangle. You can see a triangle is formed right here. And that if I subtract this from the entire thing, what I'm left with is then the pizza crust. That's amazing drawings right here. But in other words, if you take away, so if you have a segment that's, again, pretty much a slice of pizza, if you take away the actual pizza part, the part that most people like to eat and they waste the crust, then what's left over is that. So you take sector area minus triangle area, and that will equal segment area. And this is why I'm teaching you this formula, because we know how to find, you're going to know how to find sector area, what we do up here. Then how do you find the area of just this triangle, like the white section here? How do I find that triangle? Well, this formula is what you're going to use, because you're going to know the 2 radiuses, you're going to know these, and you're going to know this angle every time. And so finding this area is not going to be very difficult. Then you just subtract those 2 values, and what's left over is the crust. All right, and so question number 2 says, what do you need to know to use the triangle or the trig triangle formula? Okay, well, you need to know A, B, and C. And what those are always going to represent is you just need to know the, again, if I draw this triangle, here's what it'll look like. There's a sector. But this, I just need to know this angle, which they will give you. And I need to know the 2 adjacent sides, right? Side, angle, side. That's what these A and B and C represent. Notice the C is a capital because it's an angle. The C is always an angle because you only ever put angles here. And then the lower cases represent side lengths. But for within a circle, these will always be your radiuses. So all you need to know is the radius and the inscribed angle. So if you know those 2 things, then you can easily find the area of, again, the triangle piece, which is going to be essential for a problem of finding segment of an area, which I think is easily the most complicated type of question you'll have on here. But you'll see you can definitely do it. So let's put all this into practice. Question number 3 asks you to put this into practice with a circle here that I've drawn. Question 3 says, how do you, for a circle with radius 10 meters, so there's our radius, 10 meters. And again, since it's a radius, my center is not very good here, but just a sketch. Both of those are 10. For 10 meters, I need to find the arc length, the sector area, and then the segment area of an arc with, the other piece of information we'll need, 30 degrees. So that means this right here is a 30-degree angle, cutting off an arc here, arc AB. And so we got to do all 3 skills. We want to find this distance out here. Then we want to find the overall area of this pizza. And then we want to find the segment area. Okay, so let's work through all 3. So number 1, get my calculator ready. So number one, arc length. Okay, so that means we are going to find we need the measurement of our area, of our angle, the fractional over 360. How much of the circle are we dealing with? What fractional piece of it? We're going to be dealing with 30 out of 360. And then we're going to multiply that by the total circumference. What's the formula for circumference? Pi d. Okay, so we can start to fill this in. I'm only looking for 30 out of 360 degrees. So that's my fractional piece. That's like, I think, what is that, 1 out of 12? Times pi times my diameter. Now, of course, just be careful. Remember, that's why know what you're doing. 10 is my radius, so my diameter in this case is 20. Okay, so I can simply just multiply these together. Pi times 20 times 30 over 360. Okay, so I'll go ahead and put those, demonstrate that here. See if I can get this, not too much of a glare. Okay, I can go pi, and you can use 3.14, but I have a pi button, so I'm using it, times 20. Notice, because that's the diameter. So that's my circumference equals. So that's the total circumference of the circle. That's a basic problem here. If I wanted to know the whole circumference, there it is. But I want a fractional piece. I only want 30 out of 360 of this entire circle. So now I'm going to multiply that by, and I'm going to put this in parentheses to make sure I get the fractional part right, 30 divided by 360. So now I'm going to find just a 1/12 of the entire circle, and that comes out to 5.2. So there it is. That's it. 5.2. There's nothing more complicated once you set it up and the information's right there. 5.2 meters. So this distance from A to B is 5.2 meters. That's number one. Number two then, well, how about the entire area? What's the area of that entire sector? Well, started out the same way. Measurement of the angle out of 360. But now I'm finding a fractional piece of the area, so I'm going to use pi r squared this time instead of pi d. Fill it in. Same angle measurement, 30 out of 360 times pi. Now this time it's going to be 10 squared, which remember, 10 squared is not the same as 10 times 2 that gave us 20. This is going to be 10 squared or 100. So I can even simplify that. 30 over 360 times 100 pi. All right, and again, you could work through this in your head probably in a lot of ways, but I'm just going to calculate it right here. Take a time and show you how quickly it can be done. So again, 100 times pi. So that's the area of the circle. The circle's 314.2 meters squared, but I only want the fractional piece. So times, once again, and I could 30 divided by 360. 26.2 meters squared. Yep, there we go. 26.2 meters squared. And that's the area. Notice it's bigger because this is just a distance here. This is the entire area. Also notice this is distance between A and B, so that's meters. This one's area, so that's meters squared. Okay, and now let's do it again. You'll see a little bit more work, but now let's find the segment. So if I had a chord between points A and B, that would cut off this little bit of pizza crust here. That's your segment area. So that is, as you can see, that is the entire sector area minus a triangle formed between the center A and B. So I already know, so I'm going to want to subtract that. I'm going to want to do segment, actually, it's sector. Sector minus triangle is going to equal the segment area. I'm not writing area just for space. Okay, so do I know my sector area? Yes, 26.2. So I need to find that triangle area. Okay, well then now here you'll see your new triangle formula that I recommend you use rather than how the book says to do it. 1/2 AB sine C. Okay, the two sides of the triangle, because here's the triangle, the two sides of the triangle and the angle in between them is what these letters represent. So I can fill that in. It's not hard at all. And by the way, this number is always going to be the same because you're dealing with radius in this case. So 10 times 10 times sine of 30 degrees. That's simple. And I can simplify some of this before I use my calculator. 10 times 10 is 100. A half times 100 is 50. So this is 50 sine 30. Okay, so let's calculate that. 50 times the sine of 30 degrees, 25. Oh, that's a nice, beautiful answer. So the triangle, the delicious part of the pizza, is 25 meters squared. So I know my sector area, this, and my triangle area is this. So now I just need to subtract them, and the leftover is the pizza crust. So 26.2 minus 25, and I can just do that in my head, 1.2 meters squared. Notice these numbers should be off very close, because look how much area. It's just another reason why I call it fingernail. It's just a tiny little percentage of the overall piece. So it's almost all subtracted. Almost all of it is the triangle, and there's just this 1.2 that is this little segment area left off. So 1.2 meters squared is my last answer. So these are your 3 skills. Wrapping up the video, you need to be able to find the arc length. Use circumference, partial part of a circumference. You'll be able to find sector area, the whole pizza slice area. That's partial area formula. And then you'll need to be able to find the pizza crust, which is then your sector area, the whole thing, minus finding the triangle area, which again, I highly recommend. Hopefully you see this is so easy to do. You just have to have a calculator, compared to if you look at the examples, how the book wants you to try to find the height of this triangle, and just so much extra work. So more power to you if you want to do it that way, but I highly recommend you use 1/2 AB sine C. Okay, see you with the classwork if you need more help.